Thank you, Travis. Am I on? Okay. So first thing is what UCWISE is, and that's there's the acronym, University of California Web-Based Instruction for Science and Engineering. And what I'm going to be talking about is UCWISE in two flavors. One is we often talk about UCWISE courses, and I'll tell you how those are organized and how they differ from traditionally organized courses. And then we also talk about the UCWISE system, which is what's going on under the hood, the online stuff and the computing facility with which we can deliver these UCWISE courses. So what we're doing in UCWISE in the course format is swapping lecture and discussion time for hands-on lab. And there's a couple of things that are important here. One is that the hands-on lab is supervised by a TA. So there's a TA in all of our lab sections. And the second is that it's scheduled. So these are what in CS education terms we call closed labs. And so it's like physics, where you go to a physics lab from 2 to 5 on Wednesday or whatever. And roughly the staff-to-student ratio is there's a TA in charge of every lab section, and there's roughly 25 to 30 students in each lab section, and there's 1 or 2 lab assistants. All of their activities are delivered online, so they come in, they sit down at the lab, at the computer in the lab, and they start working in a way that I'll show you in a minute. To give you an idea of how this swap took place, so in CS 61B, for instance, our data structures course, the traditional format is 3 hours of lecture, 1 hour of discussion, and 2 hours of lab. And in the UCWISE format, we have 1 hour of lecture and 6 hours of lab. So we've swapped 2 hours of lecture and discussion for 4 hours lab. Yeah, question?
Yeah, very quick. What is a lab assistant? Is that undergraduate or graduate?
A lab assistant is an undergrad, and our lab assistants get credit for helping in the lab.
What level? You say TA, it's a GSI, I presume.
TA is a GSI, and the lab assistants range from people who have just taken the course through seniors.
Is the TA, though, I was asking, is that a senior GSI? Is it level 4 or 3? Or
No. These are typically GSI 1 or 2. One thing I want to make clear is that this is not distance learning. There's nothing remote about this. We're really depending on the students all being in the room at the same time, and also the interaction between the staff and the TA that happens in that room. So what you might guess what students are doing would be the typical programming activities that they do in any old programming course. Namely, they write programs, they analyze programs, they debug programs, they modify programs, and so on. And so that part of the course is pretty much the same as what students would do in a traditional format course. Now, the thing that's different, and things that you don't necessarily get in the traditional format course, are that there are a lot of embedded assessments in the UCWISE curriculum. So, for instance, most of the lab periods start with a quiz that typically is asking students questions about stuff that they should have learned in the previous lab, or stuff that they'll need to know for the things they'll be doing during the current lab section. We also have a tool in our in the course we use that involves the scheme programming language. We have a tool that lets students type in answers to questions, and I'll show you that in a minute, in code, and then we wrap that code around with some framework code and ship it to the scheme interpreter, and then see what it gives back and try and make sense of the results. We also have these collaboration activities. There's face-to-face collaboration in which we take advantage of the fact that these students are all in the same place at the same time. And then there's online collaboration activities as well that, for instance, one of our online collaboration tools is a threaded discussion tool. And so a lot of the homework activities involve contributing to those threaded discussions around a particular topic. We have another online collaboration tool that we call a gated collaboration tool, where we ask students a question, and a student gives an answer to the question and then gets to see a bunch of the answers of his or her lab mates. And so contrast this to what typically happens in a discussion section in a traditional format course, where the TA asks a question. What you'd like is for all 20 or 30 people in the section to be thinking about the answer, and then they raise their hand. But what happens really is that 5 people think about the answer, and 2 people raise their hand, and it's always the same 2 people. These are some differences with what goes on in the traditional course. Here's an outline in a little more detail about comparing the traditional format course with the UCWISE course. So I mentioned that in our data structures course, in the traditional format, we have 3 hours a week of lecture. And in a UCWISE course that we've developed to go along with that, there's just 0 or 1 hour a week of lecture. Lab, there's closed labs, scheduled labs in our traditional format courses as well. We've been running these lab sections in our courses since the mid-'80s. And what students do in the traditional format lab is we give them several short exercises to work on, and the idea is that they get practice working on the details of a programming language or an algorithm or something like that. So a lot of we have in the past called this sort of sandbox exercises, because you're in the sandbox playing with things. In a UCWISE format course, we have much more lab time, and so there's much wider variety of things that goes on there. I mentioned in the traditional format course, we have 1 hour of discussion section typically, and I put that in quotes because there's not a lot typically of give and take that goes on between the students or between the students and the TAs. In a UCWISE course, you get a lot of collaboration, not only from activities that are officially part of the UCWISE curriculum, but also, impromptu discussions can arise between students who are sitting next to one another or between the TA and the students. The access to the staff, so in the traditional format course, you have a big news group, and students post questions, and TAs answer them, and students answer them, and so forth. That's very cluttered. You get a lot of questions on the typical news group, namely people who have questions about this or that aspect of the programming environment, setting up something at home in their home computing environment, whatever. It's hard to kind of thread your way through what you want. Office hours, TAs in the traditional format course hold office hours, but there's a question about, students come into an office hour, and TA has to, first of all, the student has to take the initiative to go to the TA's office hours, and then what happens when they get there, TA has to figure out, well, what's the student confused about, and so forth. What's happening in the UCWISE course is that for things like the quizzes and the gated collaborations and so forth, the TA and the staff can see the students' answers to those in real time, and they can intervene if students seem to be confused. And furthermore, the TAs are always in the lab, and they get to see the students a whole lot, 6 hours a week in lab. So there's the TAs have very different roles in a UCWISE course, and I'll address that also in a few minutes. One other aspect about this is that to some extent it's very flexible in terms of pacing. So the students they come in, they sit down at the lab, at the computer, and they start working. And some will go faster than others. Some may finish the lab activities early and leave. Others will take longer. But what we're really trying to do for the purposes of helping these collaboration activities is keep the students more or less in sync. So they might get a little faster or slower than their lab mates, but the idea is to keep them more or less on the same page. Yeah, Jim?
Is the total workload for GSIs and lab assistants the same for the two different models? It sounds more intensive.
Good question. One of the things, the question was, well, does the workload compare? And the question is twofold. Does it compare? How does it compare for TAs? How does it compare for students? One of our constraints, one of our design constraints for the system was that it should be revenue neutral. So we shouldn't be spending any more time, any more TA dollars than we did in the past. And that turns out to be the case. What TAs do instead is they cut back some on their office hours. And the workload for the students is comparable also, and I'll get to that in a few minutes. Why do we do this? Basically, we noticed that in a lot of cases things weren't working. We had this situation where students were often really confused about stuff embarrassingly near the end of the course that they should have learned much earlier. And one of the students who had worked with us, she summed it up in lecture. They listened, and in lab they started to experiment, and in discussion they listened, and then they get to the homework and they struggled. And this listening, I mean, not just us, a lot of educators are kind of skeptical about the value of lectures, and at best, what a lecture provides is sort of passive learning. And so what we wanted to do is replace that with active learning. Now, we're not the only people on campus that are trying to make better use of the lecture time. So, for instance, in the Digital Chem project in Chemistry 1A, they're trying to make good use of the lecture time through a technique called peer instruction, where they flash a multiple choice question on the screen, and they have the students vote, and then their discussion ensues, and so forth. A similar kind of thing has been instituted in Anthropology 1, where Ruth Tringham is the ringleader there. She's been trying to get a lot more discussion going on in the lecture period. But at any rate, so we're trying to swap this passive learning for active learning. The UCWISE courses we put together so far, one is the first one we put together is the lab-based version of CS3. That's our introduction to programming course for non-CS majors. So we piloted that in 2002, and we've been offering that in the lab-based format since 2003. The next one was the data structures course. I ran a pilot section of that in fall 04. In fall 05, I scaled that up to the only offering of that course in the semester, and then I'll be running it again in that format next semester. A course that was designed but seems to be dormant is CS4. It was a course we put together to introduce engineers to programming in Java. That's been run a couple times. And then 3 of the UC Merced introductory programming courses have also been run in this format. So let me give you a few more details of a sample day, and this is in CS3. So when students sit down at come to the computer, they see a calendar in this form, and they go to the date, the right date, and they click here, and that pulls up. Oops, it timed me out. Okay. This is not so good. Okay, what happens if we do this?
Is there an issue in the house, Klausroff, or is this our problem with the network, or? I'm online.
I was, let's see, I was hooked up by Air Bears, and it seems to have timed me out here.
There's eats in the room.
Oh. Well, let me go on, and maybe we can use Dan's computer to demo this later. What you would have seen, is besides that that stuff is students click on it and click on the lab activities for the day, and they bring up stuff that happens. So the first thing I would have shown you would have been the quiz that starts this day. It would have been a quiz on material from the previous lab. Then a bunch of other things. There's pages they would see that would read. Follow5.ucwise.org. And there would have been some of these online collaborations, programming activities, and so forth. And follow 2. This isn't going to work. Okay. Quiz, a bunch of, I would have shown you a variety of activities. Another property of this collection of activities that students go through is that the gradient from easy stuff to hard stuff is much gentler. So one characteristic of our traditional format courses is that students do work on easy things in lab, and then they have homework assignments. And typically it's a big jump up from the low-level techniques they get practice with in lab to the homework. And then some of these courses have projects as well, and that's a big step up also from the homework. And so there's a lot of ways that students can be intimidated just from having to make these big leaps from inability from what they do in lab to homework to projects. With the luxury of more lab and more time in lab and more activities, we can provide a much gentler progression from easy to hard things. So, for instance, suppose we want to target some complicated technique. Well, we start with easy things, and then students work on slightly more difficult things and slightly harder things after that, and so forth, and work their way up more gently to the more complicated thing. Several kinds of advantages that we have for students. This format seems to be very good at helping students not to fall behind. Students are, well, if you measure the workload, students can, they're spending more time on the computer, obviously, per unit, but it's more productive work, and I'll explain that in a minute. And also, what we found is that with the much larger collection of activities that students are working on and so forth, we get a whole lot more information about about what students are confused about and what they're getting wrong. So, can you want to? Okay. Yes. The question was, the question addresses a downside of this lab-based format, and that is seats. So in 5 years ago, when our enrollment in CS3 was 350, we wouldn't have had enough lab seats to accommodate all the people. So let's see. Here's a quiz. Let's see. Another thing they do, there's some text pages that they just read. Here is one of these gated collaborations. This is the question we ask them, and then once they answer it, they get to see a bunch of answers from their classmates. Here's an example of first the computer. That was it. Yeah. Jeez. There we go. I mentioned the tool that is hooked up to the scheme interpreter. What happens here is that students type in some stuff, which could be code. It's not in this case, but it could be. And this is one of our assessments. So they type in an answer, and then they click the icon here to get... this is a bad day for demos here. X. Okay, well, this just isn't working. Yeah. So you'll sort of have to take this on faith that students really do well in this system. Let me provide a few more details. I mentioned the gentler gradient among the from activity to activity, and for a number of populations that traditionally have been underserved in computer science, one of the issues is a matter of confidence. So females, for instance, the stereotype female is sort of not so confident about where she is in the and how well she's doing in the course, and these kind of big leaps from activity level to activity level, I think, really doesn't help there. And the gentler progression of activities helps students who are not so confident to, kind of stick with it and not feel so stuck. Another good thing is that we're constantly testing the students to make sure they keep up. And what happens when we notice that they're confused is that we pounce. A term we use for that is targeted tutoring. So we see that students are having a problem, and we go and we initiate some sort of tutoring session to get them unconfused. And that, for me, as an educator, is really the most thrilling aspect about the system, in that we can help students get unconfused right away rather than wait a month for an exam to reveal that they don't know some important thing. Also, what's happening in the lab is that students get more help from each other. And so it's very easy for someone in the lab who is confused about something to talk to his or her neighbor in the lab and say, well, I don't understand this. What's going on? Yeah?
Does the instructor have control or access to the student's desktop to see them struggling, or is it by invitation only? Remote access,
Well, what happens is that it's student answers a quiz or one of these online collaborations, and the answer goes into the database, and then the TA can. Yeah, it is. It can be in real. Let's see. What happens is that the TA sees what the students have done and then goes and talks to them right away. That's right. The other, let's see. Yeah. Well, anyway, targeted tutoring is a big win. So what we see happening is that students get a lot of support to keep up in the course. In terms of working better, they do more hands-on work, but partly because of the gentle gradient of activities, they bog down less, so they're stuck less, and the instructor in the lab can help them in that way. I talk here about efficient interaction with the staff. Again, you look at the comparison with the traditional format course, and so you have this news group that's cluttered with all kinds of things and is hard to make sense out of, and you have office hours where student needs to figure out, the TA needs to figure out what the student's having trouble with before being able to help him or her. What happens in the UCWISE course is that the TAs are seeing the students 4 to 6 hours a week, and so you get to really know your students in that kind of situation. Plus, there's all this context. So the TA knows what the students are working on in a particular day. It's the daily set of lab activities. And so the TA has much more background information about what kinds of things might be causing the students' problems and much more context about how to help them. Yeah, Jim?
Do you have hard data about some of the benefits? And so, for example, how many people have more confidence in certain groups? Is there data to back?
I'll say something about that soon. One piece of data that we do have, since we have this much more vast quantity of online information, we get a much better picture of where the students are at and what they're having trouble with. And in particular, Clint Ryan, who just got his master's degree, his master's thesis was on, he had been a TA for CS3, not only in the lab-based version, but in the traditional format CS3. And his master's thesis was on the problems that students have with empty things. So empty words, empty sentences, empty lists, empty words within a sentence, things like that. And we kind of suspected that might be a problem before, but what the lab-based format allowed Clint to do was to plug in activities that the students could do that would provide a lot more information about what they were having trouble with. And we've seen this in every UCWISE course we've put together. Namely, we have a much greater amount of information about where the students are at and what's causing them trouble. There's advantages for instructors, too. So I mentioned this business of exposing student misconceptions. And so in what little lecture these courses in the new format provide, you can really focus it on what students need from a lecture, what they're having trouble with. And you can organize your lecture about things the students need rather than what's in the book or what's not in the book or what the instructor lectured on the previous semester or whatever. Also, not all of us are great lecturers, and what I think this provides, less lecturing, but it lets the instructor really play to his or her strengths. So for my part, for instance, I really enjoy cooking up things for the students to do. And curriculum tuning is something I did a lot the last time I taught CS3. And it turns out to be fairly easy to kind of plug and play activities into the curriculum. So I've told you now how the courses look to the lab instructor and to the TA. Now I want to say something about what goes on under the hood. So there's a database of these course activities, and they're annotated, and there's roughly 500 of them per course. And where these are stored is in the WISE system, which is a learning environment constructed in the school by people in the School of Education under the direction of Marcia Lin there. We have 3 windows onto this database. One is the student portal that you've just seen. It's where the students get their activities and so forth. There's a curriculum builder, which we use to build courses from scratch. And then the intent is for there to be a course builder, which a prospective instructor might use to build a course using our raw material. And I mentioned the motivation for getting started. One was the educational motivation that I pointed out about the value of lectures. The way we got into this was that at the very beginning of the CITRIS proposal formation, people at UC Merced came to us and said, could you somehow install your lower division courses at Merced so that we don't have to reinvent the wheel? And so we thought about that and we said, well, maybe they won't like our courses. And so where we sort of focused our efforts is in designing a system that prospective instructors could use to build a course out of our raw material. And I'll talk in a minute about how far that's come along. So we have short-term work, and that involves mainly just building in more tools into our learning environment for the students to use. So I mentioned this assessment tool that was able to route answers through the scheme interpreter. A group in the software engineering course last year built a Java version of that we're going to try and incorporate into next semester's 61B. We've got a hold of a algorithm visualization tool from some people in the Midwest, and so we'll be trying to work that into the course also. Dan Garcia is the head of a project to make, we've been webcasting lectures in the lower division for several years now, and Dan's heading a project to make all that accessible by topic and so forth, and we're going to try and build in access to lectures as well into the 61B curriculum. Also in the short term, we had a group in the user interface course redesign the interface for the student portal, and so we've got a design for that. We just need to get it implemented. We always have ideas for ways to help the staff keep an eye on what the students are doing. And what we'd like also is to provide some integration with some IDEs that are out there so that we could get more information about what students do when they're programming. So right now, in order to actually write a program, they have to leave the UCWISE environment. In 61B, they use Eclipse. In CS3, they use Emacs and a scheme interpreter. And it would be nice to have a programming environment with a little more connection. In the medium term, we noticed that what we have here is basically a digital library. And the big difference between our digital library and your standard digital library that people are putting together elsewhere in the country is that we don't just have isolated learning objects, we have entire courses. And so one of the things we have to do is figure out a way to allow browsing that library, and so that involves that provides a need for metadata and annotation of the various things in there. But it may be that since we have these courses instead of all these little isolated things, we might want different metadata. We might want to access the stuff in the library differently from the way people do in the existing digital libraries. One tool that Andy Carl, who's sitting over there, a tool he put together is a tool that annotates pieces of curriculum with pedagogical patterns. And what a pedagogical pattern does is distill some aspect of running a course. So for instance, one such pattern you might refer to by the name early warning. So if you're covering material that builds on things, you really don't want students to get lost, and you want them to keep up. And so what you might want to build into your course is some way for getting feedback on where the students are, so you can support them as they move through this material. And so one thing we're looking at is using these is higher level metadata. These using not just keywords, but these patterns for metadata. And another thing we're looking at it for is for use as a curriculum authoring tool. So if a lot of times you're writing a curriculum and you say, okay, I want an instance of this pattern, and then you can use that, use the database to fill in the blanks there. In the longer term, so this is sort of just a gleam in my eye now at the moment, but it's what we're hoping to end up with is the course builder, the part of the system that lets prospective instructors build a course out of our raw material. What that will involve is a lot of richly annotated course activities. And the kind of thing that we'll be wanting is things like, well, we have a course in CS 170. It's our algorithms course for juniors. And I taught that course a couple times. And the way in order to teach it the first time, I went to Jim Demmel, who had taught it the semester before, and I said, give me all your stuff. And he did. He, dumped a massive pile of paper on my desk. And so my organization for that course the first time around was pretty much the way he did it, but it was often the case that I'd look at some exercises or topic coverage or something, and I'd say, well, why is he doing this here and in that way? So what was missing, and what I didn't really have time to go and bug Jim about every day, was the rationale for why he did things the way they did. Another thing we like in this system is what I call a critical review facility. So you have a prospective instructor building a course, and you'd like something looking over his or her shoulder that says, this is a good thing to do, given what you built into the course so far. So for instance, in 61B, one of our projects is a program to solve sliding blocks puzzles. So an instructor putting together a data structures course might build in, might see that project and say, oh, okay, I'd like to have that project in my course. And then the system would say, well, in order to be ready for that project, students need to know about backtracking search. They need to know about hashing applied to something that isn't a string. They need to know these various programming techniques. And here are some suggestions for activities that would help the students to acquire the prerequisite skills for that project. Another thing relating to 170, I taught it two times in a row. So I'd done it the first time the way Jim did it. And then the second time I decided that 2 topics needed to be switched. Well, that was fine, except for I overlooked some dependencies. So I had to sort of play catch-up when I got to the first topic and said, uh-oh, we need to cover this stuff. And this critical review facility would provide a check on that. Another thing I'd like to see it provide is just access to a community, not only of users talking to one another, instructors talking to one another, but also, for instance, in CITRIS, there's a lot going on that's pedagogically interesting. So Paul writes telelabs and various other things. And so members of the community would not just be the teachers, but the developers of the software. Finally, computer science just was visited by ABET, the accrediting agency, on Monday. And it's always kind of a pain to put the stuff together for ABET to show them, what your course is doing and what your goals for the course is and so forth. And my goal for the course builder is that you can just hit a key and it'll dump all that out and make life much easier for activities like asking for articulation and accreditation. The instructional staff, there's a lot going on in having to do with instruction. So tuning the curricula, we're always looking at the curricula to see what worked, what didn't work, how can we improve various things. We're inventing new curricula. So 61C, our machine structures course, is we've started working on that. A National Science Foundation is supporting us to develop a Java-based intro course in this lab-based format. TA training, there's always stuff that needs to be doing there. So one thing that surprised us, for instance, about the interaction of TAs with students is that sometimes the computer science TAs were reluctant to use the technology. So they thought it was a little weird to be, quote, spying on the students. And so we had to kind of tell them that that was okay. Another thing has to do with these targeted tutoring sessions. what I know of the tutoring literature has a lot to say about what happens when the student initiates the tutoring session, but not a lot about how the tutor should initiate the tutoring session, because the student often doesn't even know that he or she is confused. And so how do you initiate that targeted tutoring session without putting the student on the defensive? And then there's this whole question of, once you've got the student relaxed and so forth and aware that there's some problem, how you deal with it. Another thing we're doing, we're just surveying, interviewing, gathering data. We have much more data than we have people to analyze it. In the higher level educational research, there's a lot of variables: course content and goals, the learning environment, the learners. In our first version of CS3, we ran it in the summer, and we gave what was pretty much an identical final to a course, a version of CS3 that I'd run previously in the traditional format. The students in the summer pilot course did roughly a standard deviation better. So that's a little bit of data. Now, that data is full of holes in that the summer students are different from the regular students in a lot of ways. What we did for the next couple years is tune that curriculum. So we were not focused so much on figuring out what made the lab-based version better or worse than the traditional version, but we just wanted to figure out how to make the lab-based version better. And it's only recently, within the past year, that we've been gathering data to provide baselines in the other courses that we eventually want to have lab-based versions of, to provide information about A/B comparisons. How is the lab-based version better or worse, and why? There's some really tantalizing stuff there having to do with gender. So for instance, in CS3 2004, there were 7 of the top 10 students in my class were females, and the females did, on the average, half a grade better, and that had never happened to me before. And so we're trying to follow through on some of that in both CS3 and 61B. So summary, we're developing curricula using these tools. We aim to provide customizable course construction, and what this all provides us is a context for a whole lot of educational research into concept misconceptions, activities, effectiveness versus learning goals, and so forth. And what I've been reminded to, if any of you are grad students, for instance, are in a position to get involved in educational research, we have lots of users. That's a good. You can get a high ends for your studies. Some acknowledgments. CITRIS gave us a lot of early support. Thank you. The CITRIS ITR supported us in the early days. We've gotten funding from Hewlett-Packard. We're in the second year of a National Science Foundation grant from the Division of Undergraduate Education. And the WISE and TELS projects headed by Marcia Lin in the School of Education have helped us a lot. Affiliated people, me of course, the faculty that have been involved, Nate Titterton, Marcia Lin, John Canny is Andy's advisor, so he's involved from the research end. Dan Garcia was sort of a front person for making the change from the traditional format CS3 to the lab format. Several grad students. We've depended a lot on undergrads. Undergrads built most of our system. And that touches on two things. One, it's so neat that Berkeley undergrads are interested in education, and the other thing is that the talent is just terrific, and it's neat how much they've been able to get work done. And I've left probably 2 minutes for questions, but if you don't get your question answered, here are some websites that you can find out more information about. So thanks very much for your attention.
And if you have any questions for Professor Clancy, just raise your hand and I'll bring this up.
Mike, I'm just wondering if you see any possibility of these courses and the way the labs are created being modified for a distance learning mode operation.
One of the things we thought about early on in our work with Merced was we had thought about setting up a pilot section of CS3 there and then having our TA here at Berkeley manage them. Now, they only had 2 students in that pilot section, so it didn't happen. But it's been sort of in the back of our minds. Another thing we've thought about is having classes run by somebody that's not so much an expert, but having a mentor teacher available remotely, and so that's kind of the thinking we've gone through along those lines.
Thank you. Curious about the numbers on a typical day. How many students are operating on this system? What's the min? What's the max? What's your aggregate since launch? Just roughly curious how many students. Next
semester, we'll be running the lab-based CS3 and the lab-based 61B. I expect to have between 125 and 150 students running 5 or 6 lab sections in 61B, and Nate Titterton will be running CS3, and again, it's probably the same number of students, 125 to 150, 5 or 6 lab sections.
And one more. Yes.
I'm just curious if you've seen any difference in the body of knowledge that students would have coming out of CS3 in the traditional form and then coming out of the more innovative form. Is the body of knowledge the same that prepares them for the next step, next course?
We've been tracking that for some time in CS3, and it's sort of complicated by the fact that so what we're looking at is how CS3 students do in 61A, which is the first course in our sequence for majors. And it's complicated by the fact that the people that take CS3 are the less well-prepared people in the first place. And so we're not quite sure how to compare those to people that have learned to program elsewhere and are starting in 61A. What we're gathering now, we put into place surveying, end-of-semester surveys in all of the 61 series courses, and so we expect to be able to track people at least through the lower division sequence. And so, so we're starting to get that data.
Well, thank you so much, Professor Clancy, and let's give him another round of applause.